Have you ever really wondered what a cybersecurity analyst does all day? Well, today we're going to crack open their digital toolbox and build one for ourselves piece by piece. We're going to see the essential gear they use to fight all kinds of digital bad guys. So let's get into it.
Okay, picture this. Digital alarms are screaming, sensitive data is flying out the door, and a company's entire network is grinding to a halt. They're under attack. In that moment of pure chaos, who do you call?
You got it. The cybersecurity analyst. They're the first responders of the digital world. And trust me, they don't show up empty-handed. They come prepared with a very specialized toolkit. And today, we're going to build that exact kit from the ground up. All right, here's the game plan. First, we're going to lay the foundation, the core knowledge every analyst has to have. Then, we'll bolt on our defensive tools. After that, we'll pack the gear we need for investigating, for when things go south. And we'll wrap it all up with the most important thing, the crisis playbook.
Okay, first things first. You can have the fanciest tools in the world, but if you don't understand the environment you're working in, they're useless. So we have to start with the foundation, the code, and the systems that make the digital world go round. At its core, programming is really just giving a computer a super specific to-do list. And for a security analyst, this skill is an absolute game changer. I mean, can you imagine trying to manually search through millions of lines of data? No way. With a simple program or a script, you can automate that whole process, which lets you focus on the actual threats and seriously cuts down on human error.
For an analyst, programming really comes down to two different jobs. On one hand, you've got languages like Python. Think of this as your builder. It tells the computer what to do. Go scan this, sort that, automate this repetitive task. Then, on the other hand, you have languages like SQL. This is your detective. It asks the database for information, digging through mountains of data to find that one tiny clue. One is about action, the other is about asking questions. You absolutely need both.
So where do you run all these powerful programs? Well, a lot of the time, it's on an operating system called Linux. Now, it's really important to get this straight. Linux is not a programming language. It's the environment, it's the digital workshop where you use your tools. And because it's open source and you control it with text commands, it gives security pros an incredible amount of power and fine-tuned control.
All right, our foundation is solid. Now it's time to build our defenses. These are the tools that are on guard 24/7. Think of them as our digital shields and high-tech alarm systems.
First up, we've got a classic you've probably heard of, antivirus software. This is your frontline soldier, your bouncer at the club door. It's always scanning for known bad guys, viruses, malware, that kind of stuff. And it gets rid of them before they can cause any real trouble. It's absolutely fundamental.
But what about the threats we don't know about yet, or just, weird, suspicious activity? That's where an intrusion detection system, or an IDS, steps in. This thing is like a security guard that watches everything happening on the network, analyzing all the data flying back and forth, looking for any sign of trouble.
And this is the perfect way to think about an IDS. It's not a brick wall. It's not a force field. It won't necessarily stop an attack all by itself. What it is a silent alarm. It's the motion detector that goes off in the middle of the night telling you, the analyst, hey, something's not right over here. You need to come look at this now.
So, the silent alarm just went off. An intruder might be in the network. We have to switch from defense mode to investigation mode. It's time to pop open the next compartment in our toolkit, the investigator's gear.
And the star of the show here is a tool called a SIEM. That stands for Security, Information, and Event Management. Just think about it for a second. A big company's network generates millions, maybe billions of log entries every single day. A SIEM is the magical tool that drinks up all that data and makes sense of the chaos. It's designed to find that one single event, the needle in a continent-sized haystack, that signals a real attack.
And the workflow is actually pretty simple and logical. The SIEM just inhales this flood of data, it hunts for any suspicious patterns, and then, bam, it sends a very specific alert to the analyst. That alert is basically the starting pistol. It tells you exactly where to begin your investigation.
So once you get that alert, you need to see what really happened, right? You need the nitty-gritty details. That's when you fire up a packet sniffer. This tool lets you capture and inspect the actual data flowing on the network. It's basically like putting a wiretap on your own system, letting you see every digital conversation and figure out exactly what the bad guys were up to.
Now, tools are awesome, but you can have all the best tools in the world, and if you don't have a plan, they're just expensive gadgets. So, the final, and you could argue the most important part of our toolkit is the crisis playbook. This is your step-by-step instruction manual for when everything hits the fan.
Let's make this super real. A medical clinic just got hacked. Sensitive patient data is at risk. You're the one they call in to figure out what happened. You can't just start randomly clicking around on machines. You could destroy the evidence. You need a clear step-by-step procedure. You need that playbook.
And one of the most critical concepts in that playbook is the order of volatility. Now that sounds complicated, but the idea is pretty simple. Some digital evidence is incredibly fragile. Think about the data in a computer's active memory. It's RAM. That data is volatile. The second you turn that computer off, poof, it's gone forever. The playbook tells you the exact order to collect evidence in, starting with the most fragile stuff first.
And the stakes here are just incredibly high. This quote says it all. If you don't follow the playbook, if you get that order of volatility wrong, the evidence you find could be compromised. It becomes totally useless for an investigation, and it'll get thrown out of court. The playbook is what ensures you get it right every single time.
And there you have it. Our first cybersecurity toolkit is officially assembled. We've got our foundational knowledge, our code and operating systems. We've added our defensive gear, the antivirus and the IDS alarms. We've packed our investigators' tools, our SIEM and packet sniffers, and we've tied it all together with that crucial crisis playbook.
This is an amazing starting point. But here's the thing about a cybersecurity toolkit. It's never really finished. The world of digital threats is constantly changing. New attacks, new malware, new techniques pop up every single day. So the real question isn't whether this toolkit is complete. The real question is, now that you have this foundation, what new tool will you add next?